All right, ladies and gentlemen, I need you to get these formulas back in the front of your brain.
Because it's not in the front, it's in the back.
It's in the back. It's been a while since we did some of these. Now, a couple of these we've been using over and over again during the review, so you're probably ready for those. For example, these first two. We know that if the angle is at the center like this, the angle and the arc will be the same thing. All right, we've been doing that for the last couple days. The second one, I feel like you're real familiar with by now. When it's at the edge, inscribed, the angle is always half the arc. The arc is double the angle. Now, these other two are the two that we haven't looked at for a while, so let's get these guys back in the front of our brain. These are the ones we use when the angle is inside the circle, but yet it's not at the exact center. It's off center. So this is where we have to use these formulas. This really is the average. In this situation, the angle is the average of the two arcs. It's the average of these two arcs right here. So add them up and divide by 2. That will give you the angle. That's when it's inside the circle. If you have an angle going outside of the circle, it's almost the same thing, but it's subtraction instead of addition. So big arc minus small arc divided by 2. So let's see how this would show up in a problem. Okay, look at problem number 1. Looking at the 60 down here. With an eye on that 60, you should be able to immediately tell me what the measure of this arc is going to be.
90.
It's not going to be 90.
About 3.
It's 120 actually.
Arc KS is going to be 120.
That's
Okay? I'm afraid that you guys don't see it. It's 120 because, let me highlight. Look at this angle right here. All right, see the yellow angle I highlighted? The 60 and the 120. Inscribed angle with its arc. It should be double the 60. Is that clear now?
Yep.
All right, in the same way, you should be able to tell me about arc UT. What's the measure of arc UT? 80, Connor said. It's the same thing, it's double 40. All right, just like the 60 we doubled it, the 40 is doing the same thing to the 80. Does that make sense? You see it? Okay. Now, we've answered one of the questions. We were supposed to find the measure of arc KS. So what was that?
120.
That was the 120 that we already found. But we haven't done this yet. We're supposed to find the measure of angle KNS. Now, please understand. Nice. KNS is this angle right here that I just put a theta on it. Okay? That's angle KNS. Now, listen to what Clara said. Clara said, hey guys, look at this X in here. Focusing on that X right there, can you see that this is just this third situation where we have angle inside but not at the center, and then we have two arcs that go with it. So we're going to use the old angle equals arc plus arc divided by 2 formula. So that's what we had to do for number 1. Okay, so let's do that. So that means angle, this angle should equal 120 plus 80 divided by 2. All right, that's 200 divided by 2, that's 100. Whoops. Okay, does everybody see why the answer is 100? Did I lose anybody? Okay. Let's look at number 2. All right. I need somebody in the first 2 rows set up the equation for me? Anybody in the first two rows, can you set it up for me?
Chuck.
Madison.
X is 140.
Wait, is it?
I need the equation.
Is it
All right.
55 plus X?
Over.
No, 70 equals 55 plus X divided by 2.
Thank you. Oh, I'm so happy that you said that. We're still using this third model where we have the angles inside the circle off center. So angle equals arc plus arc divided by 2. Notice that we start with the angle. Focus on that. So looking at problem number 2, Stephanie's recognizing that the angle is 70. That's what we begin with. So that's why she said 70 equals. And then it's arc plus arc divided by 2. So that's x plus 55 divided by 2. So then it's just a matter of solving this. How do I solve this equation, you guys?
Times by 2 on each side.
By 2 on each side. So that gives us 140. These 2's cancel out. So I have x plus 55. What now?
Minus 55.
Minus 55 on both sides. So that's going to give me x equals something. 85. So that's why the answer to number 2 is B. Any questions on how we did that? Okay, moving on. Okay, looking at problem number 3. We are given that angle QTU is 60. So let's see, where is that? QTU. All right, watch this carefully. I usually lose a few people on this next step. Are you ready? We're given this angle right here. Now, you guys know all about inscribed angles. When you have an angle that's at the edge of the circle, you double it, it gives you the arc. I need you to understand that this angle that they just gave us, this 60, that is an inscribed angle. I should be able to double this, right, Austin? I should be able to double this and get some arc. It's just a matter of which arc am I doubling. This is the arc that goes with the 60-degree angle. Okay? So if this angle is 60, what's the measure of the arc QT? Arc QT is 120. Did you guys follow that? Do you see why the red arc is 120? Okay? The rest is usually not very difficult for you guys. That's the part where I usually lose people. For example, knowing what the blue arc is, you guys usually don't have a problem with that. Who can tell me, blurt out what the blue arc is? Somebody said it.
80.
It's 60. Braxton said 60. Why?
120 plus 60 is 180.
Yeah, always watch out for your semicircles. When you're dealing with a circle problem, semicircles give you a lot of information. So you see this is a diameter, goes right there at the center. This is a semicircle, 180 degrees. So it makes sense that if the red part, I lost my, there it is. If the red part is 120, then subtract from 180, you get 60. So I've got that. Now here's some other things that I know. I should know this blue angle right now, shouldn't I? What's the measure of this blue angle? That's 30. Inscribed. It's at the edge. It's half of the 60. I'm matching colors. Let me do it again. Tell me what this red angle is. That's going to be 60. Same reason. It's across from the 120. Okay, so that's going to be 60. Now it's time for me to pause and look at what I'm actually being asked to find. Angle QPT. Let's see. QPT. We already found that. What is it? That's 60. It's right there. We're supposed to find angle PQT. PQT. We already found it. What is it? Wait, only Greer? Come on, people.
30.
All right, the measure of arc QT. What's that?
120.
120, thank you. What about arc PT? 60. Okay, now the last one we haven't found yet. We're supposed to find angle QSU. It's this one that's hanging way outside the circle. I'm going to put a theta on it. We need to find that angle out there. Any ideas?
30.
It's not going to be, well, how are you finding it? I want to know a process.
20 minus 60 over 2.
X minus y over 2.
Yes, thank you. We have to use the fourth formula over here. When the angle is hanging outside of the circle like that, the angle is arc minus arc divided by 2. So that's what we're doing. Arc minus arc divided by 2. Whoa, overshot. So that's why. So we're going to say the angle is 120 minus,
Over 2. You get 90.
you get what?
Oh, maybe I did it wrong.
120 minus 60 is 60. Divided by 2, so I'm going to get 30.
Oh, sorry, I put it weirdly in my calculator.
All right. Okay, so that's it for that one.
You did plus 60.
Did I lose anybody?
No.
Okay.
Yes.
Oh, you'll figure it out. You're super smart. Oh, wait, there's an F. There's an F. We got to talk about F. All right, to do the F, I need to erase some stuff, though. Oh, no, that's not okay, sir.
What?
The question for F is it possible to draw this picture so that QTU is 45 degrees?
Yes.
Let's investigate that. Let's start from the assumption that QTU is 45 degrees and see what happens. Okay, if QTU is 45 degrees, remember QTU, that's this angle right here. So the question is this allowed to be 45 degrees? Well, remember how we did the problem last time, when it was 60 degrees. If this is 45 degrees, tell me what the measure of this red arc is going to be. That red arc is going to be 90, because it should be double this inscribed angle.
What?
Remember what we did last time? We did the rest of the semicircle. Okay, we did the rest of the semicircle. So if the red arc is 90, what will be the measure of the blue arc? That will also be 90. Now, let's talk about the theta. If I now wanted to go ahead and find this angle that's hanging outside the
It's
circle,
going to be 90.
how would I do it? Set it up for me.
Oh, wait. It'd be 0.
Just set it up.
90 minus 90 over 2.
Right, when we're outside the circle like this, the angle is arc minus arc divided by 2. Minus. So when we sit here and do 90 minus 90, whoa, that's weird. What's that going to make?
0.
That's 0. 90 minus 90 is 0 divided by 2, which is 0. Can you have a 0 degree angle? No, you can't have a 0 degree angle. So no, there's no way that we could make a picture so that this was 45 degrees. That would be a 0 degree angle. So that's why that's a no.
No, that can't happen.
Okay, moving on to the back page. Thank you. All right, so Mr. Perez, here's the situation. We're given this 72 degrees right here. Let's see. We're given the fact that arc MN is 3 times as big as arc JK. So look at this, you guys. This is arc JK. There's a K up here. So here's arc JK. Let's say I call arc JK X. I'm going to call that X. The problem here says that this arc is, the other arc is 3 times as big as JK. So if I call this one X, what expression can I use for the other one? it should be 3x, okay? If it's 3 times as big. So I'm going to call it x, and I'm going to call it 3x because it's supposed to be 3 times as big. Now, you have to remember those formulas. Look at the top of your paper and the front. Remember these formulas? Which one of these 4 situations am I in? First, second, third, fourth. Can you see I'm in the third situation? So hold that formula in your mind. Angle equals arc plus arc divided by 2. That's what's about to happen. Okay? Angle equals. So I'm going to start off with 72 equals arc plus arc. So that's x plus 3x divided by 2. Do you understand what I'm doing? So it's just a matter of solving this little equation. So what do I get when I do x plus 3x, you guys? 4x. Very good. X plus 3x is 4x over 2. Now 2 divides evenly into 4. So let's go ahead and do that. So I'm going to get 72 equals 2x. How am I going to get x by itself now? Yeah, just divide by 2. So here I go. Dividing both sides by 2. That gives me x equals 36. X equals 36, you guys. So, let's see, I'll go purple. That tells me x is 36. So that means this arc up here is 36 degrees. That also should tell me what this arc is down here. Because it shouldn't be 3 times 36? Thank you. If x is 36, then this means do triple it. So Jesus told me, get the door for me. Jesus told me that this will be 108 because I multiplied by 3. Did I lose anybody just then? Now I've got both of these arcs. I'd like to know what the other arcs are. Let's see. How could I find the other 2 arcs? Nobody? How many degrees are there total in a circle? So what am I about to do? I'm about to, she said 360 minus. Okay? If I subtract the 2 angles that I have already, so minus 36 minus 108, tell me what's left. I heard 216. So I have 216 degrees left. But how do I know how much to put on each one? Divided by 2. We're told that JM and KN, they're congruent. They're the same. So we have symmetry. So divide by 2. And what do you get then? 108. That means these 2 sides are both 108 degrees. All right, so now I think if we look, we'll find that we've answered all the questions. So JK, that was x here. That was 36 degrees. MN, well, all of the rest of these are the 108s. Okay, that's how you do number 4. Any questions? Okay. Now, number 5 is complicated. This one is next level. In fact, I need a lot of space, so I'm going to scroll down where I made a bigger copy of it at the bottom. So even my geniuses, I really recommend, should probably stop what you're doing, pay attention, because maybe you had trouble, I don't know. Half of the trouble is understanding what they're telling you and drawing the picture, okay? So let's see. They say there's a circle with center at 3, 4. So you see I've drawn here a circle, and the center is at 3, 4. So far, so good. They say the radius of the circle is radical 3. So you see I've drawn a radius here, and it has the length of radical 3. Okay? Why did I put it exactly there? You'll see with the rest of it. They call it circle O. So I need you to understand that when they call it circle O, that means the center of the circle is point O. So that point in the middle is O. What else did they tell us? Point P is located at 7, 0. So here's 7, 0 down here at the bottom. So I call that point P like they said. All right, what else? We're supposed to find the length of PT. Well, where's this T? This is the first I'm hearing about T. What are they talking about? The segment from point P that is tangent to the circle at point T. So that's why I drew this line. That's why I drew the line from point P, and I have a tangent just barely touching the circle. That's a tangent. And I called that T just like they said. And that's why I went ahead and drew the radius at that point. So that's where I put my square root of 3. So half the battle is coming up with this picture. Taking all those words and getting to this picture. Do you understand where I got this picture from? Their words. Okay? Now, what part of this picture am I supposed to be finding? PT. We're supposed to find the length of PT. Now, can you see where I'm going to draw a triangle in a minute? Can you see like two-thirds of a triangle sitting there waiting for me to draw the other piece? So this is the triangle I'm about to draw. See if you were right. If I go ahead and connect OP, right, that completes that triangle for me. Do you know that this is a right triangle?
Yes.
Tangent and a radius are always perpendicular. That's one of our special properties. So we know that this is a right angle right up here. This is 90 degrees. So we're going to have to do two things. Pythagorean Theorem is coming. We're going to end up using the Pythagorean Theorem to find PT. But look, right now I have radical 3. That's one side of my triangle. I need the hypotenuse here. I need at least two sides before I can use the Pythagorean Theorem. How could I find the length of OP? That's why, as a hint, I gave you well, it's not on this side. On your paper, you'll see that distance formula. It won't be given to you, I don't think. I don't remember. I don't think you're given the distance formula on the formula sheet. So you need to know this distance formula, okay? You have to memorize that. So that's what I'm about to use, that x minus x. Oh, you know what? I made a mistake. I need you to fix this on your paper. The formula is missing the squares. So I felt really bad about that. But please correct this now. That's what I get for working at midnight, because I make mistakes. These are supposed to be squared, you guys. I'm embarrassed. So these should be squared. So please fix that. Do not learn that wrong because of my typographical error. So x minus x squared, y minus y squared. So that's the distance formula. That's what I'm about to use right now. Okay? So you see I've got the point 3, 4, and I've got the point 7, 0. That's what I'm about to do the distance formula with. So here I go. Okay? So my distance, can y'all see that? The distance is going to be the square root of, let's see, x minus x. So let's say 7. 7 minus 3 squared. Keep going. 0 minus 4 squared. Okay? Now, you could work it out by pieces if you wanted to, or you could just type the whole thing in your calculator. Either way, you're going to get, what'd you get? 4 root 2? In the end, you should get 4 root 2 for this distance. So verify that. Okay? So what I have found is the hypotenuse here. All right? So now I found that this side of my triangle is 4 root 2. Now I have two sides of my triangle, and I'm down to finding the third side. All right, let me make this ink a little bigger. Okay, so I'm just going to do the Pythagorean Theorem. I'm doing my a squared plus b squared equals c squared. Okay? And the 4 radical 2, that's my c, right? So here I go. I'm going to do radical 3 squared, that's my a, plus, and I'll just call this b for a second. So plus b squared equals 4 radical 2 squared. I'm just doing my a squared plus b squared equals c squared. If I do radical 3 squared, that's just going to give me 3. Maybe you know that if you square a radical, the square and the radical cancel out, and it just gives you whatever's inside. If you didn't know that, your calculator would remind you. So I get 3. So I've got 3 plus b squared equals. What did you get when you put 4 radical 2? Let's see. It should be bigger than that. 32. Yes, if you're going to put this in your calculator, the parentheses are necessary. Otherwise, it's only squaring the radical 2 and not the 4. So you should get 32. So what am I about to do now? So now I'm about to subtract that 3 from both sides. So that gives me b squared equals 29. Now what? Square root both sides. So that's going to give me b equals square root 29. Now that's what I was supposed to find. That was the length of PT. So I look back at my choices, and what's the answer? That's why the answer is C. Okay? Now I realize that was complicated. There were a lot of steps, but I believe that you can do it. Okay? On the EOCT, the bad news is it's kind of tough. They put a lot of problems like that on there that have many steps and are difficult. The good news is they curve it. Okay? So they tend to curve it a lot. So if my students come into this thing knowing how to do problems like that, exceeds, baby. That's what I'm shooting for. All right, let's knock out these other two. So looking at number 6. We're told that this is a square. AE is 3. All right, let me make this bigger. All right, watch this, you guys. We're told that AE is 3. Okay? So that's 3. Okay? What else do I know? We're supposed to find the length of DF. So we're supposed to find this little guy right here. Okay? Alright, here's the key to a problem like this. David could tell you, what's the radius of this circle, David? Give me a number. Can you see that this 3, the AE, that's the radius of the circle? Now, in a circle, the radius is so important because I could draw this radius anywhere I wanted. I could put it out here. This going straight down, this is another radius. So if I needed to, this would be 3. But what about the diagonal of that square? Because I need some triangles so I can do what I do. Look at the diagonal of this square, you guys. How long is the diagonal of that square I just drew? Can you see that that will be 3? Because it is a radius just like all the rest. So that's 3. That's the key to the whole problem, is drawing that line and knowing it's 3. Okay? Now, how many degrees are in this triangle? You see this? This is a 45, 45, 90 triangle, right? Because it's half of a square. So we can use our properties of 45 degrees. Now, it is the slightly more difficult version because they gave us the hypotenuse. Okay? They gave us this 3. And the hypotenuse, when you look on the model, on the poster over the board, what do you see on that hypotenuse? We see x root 2. That means this 3 must equal x root 2. So what am I about to do? I'm about to divide, yes? So I'm going to divide both sides by root 2. Okay? So this is going to give me sort of an ugly expression. I think it's going to give me 3 root 2 over 2. Not very pretty. But understand that this x that I just found, that's the length of a side of the square. Okay? So, this is a square. All the sides are the same, right? Even AD. AD is the side of a square. So AD is 3 radical 2 over 2. Now I'm ready. Okay? This takes that extra part of your brain, so really concentrate. If I know that the whole length from A to F, let me scroll up a little bit. If I know that the whole length from A to F is 3, and if I know that from A to D is 3 radical 2 over 2, what operation would I have to do to find x? Thank you. Can everybody see that we need to subtract to get the leftover part for x? Okay? In other words, we need to start with the 3, which is the bigger length, and we need to subtract the smaller length of 3 root 2 over 2. If I do that, that should give me the length of x, the leftover part. Okay, that was a lot of steps. Raise your hand if you felt like you followed what I did. I'm so worried that I lost a lot of people. Just raise your hand if you followed, you got it, you understand. Okay, put your hands down. That was almost everybody. So, what's the answer to the question? Can everybody find that the answer then is D? That's where they got this from, 3 minus 3 radical 2 over 2. That's how they did it. Wow, that was complicated. So this might take practice. You might need to come back again another day and see if you remember it. See if you can do it on your own another day. But for now, we move on. All right, last problem from yesterday's worksheet. Okay, looking at this one. We are supposed to find the measure of angle ACE. Okay? So we're supposed to find, so ACE. We're supposed to find this angle right here. I'm going to put a theta on it. That's almost a hint right there. Okay? Remember those formulas at the top of your paper at the front. Which one of those 4 situations am I in?
4.
Can everybody see I'm in the 4th situation? Okay, my angle outside the circle. So I'm about to do angle equals arc minus arc divided by 2. That's what I need to do now. Got it? Okay, angle equals arc minus arc divided by 2. Now, do I have both of the arcs that I need right now? Not yet, do I? I have one of them. Let me color it. We need this arc, which I've got. But we also need this arc, which I don't have yet. Alright? I need those 2 red arcs to do the equation that I just mentioned. So our next goal is to find this red arc. So let's play around with the numbers that we have until we find it. So let's see, what can I do? Well, the only other number I've got is this 84. Now please be really, really careful here. Watch this. Look where the 84 reaches to. If I draw out the arms of the 84, Do you see how the 84 reaches to here and here? Okay? So the 84 reaches from here to here. So it doesn't just give me AED, it gives me all of this. I'm going to highlight it. So the 84 is going to give me this arc that goes all the way like this. Okay? Now, tell me the measure of that arc that I just highlighted. I'm hearing 168 as the most common. Okay? What are you doing? Okay, 84, and what'd you get?
168.
168, okay. So this yellow arc here that I just highlighted, 168, the whole thing. Now, I need to know just ED. I'm running out of colors. Orange. Is there a pink? I'll use this for you. Okay, I need to know this. So talk to me about this arc that goes like this. I heard subtract, I heard 112. Okay? If the whole arc is 168, and this little piece over here is 56, so I'm about to do 168 minus 56. And that should give me this piece in here. Is that 112? Okay? So that's why this piece right here is 112 degrees. Okay? Okay, so that's 112. I still need the rest. Can you tell me AB? Can anybody show me how to find the length of arc AB? That's the last piece that I need. Let me color it for you. I need this blue arc down here. What am I going to subtract?
What do you guys think?
Oh, okay. Oh, you know what? I don't need the blue one. I don't need the blue one. I'm sorry. Delete. I don't need the blue one. Because of symmetry. I almost forgot. See these marks? AE and ED. They're the same. We're told that right from the beginning. These two are the same. So you should be able to immediately tell me the measure of this red arc right now. It will also be 112. Okay? Symmetry. These two match. If this is 112, this is 112. So, I now have the two arcs that I really needed. I needed the 56 and I needed the 112. Those are the two I needed. Now I can go ahead and do the formula. So the formula was angle equals arc minus arc divided by 2. So angle equals 112 minus 56 divided by 2. 28. Okay? Was this multiple choice? So the answer was A. Any questions?